Three methods of proving triangles similar. Okay. Here we go. 16, three ways we had. Similarity, right? Yep. And? Yep. Angle, angle. Perfect. What'd you have to know about the sides in side, 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 and side, angle, side? What did I have to know about the sides? 27? Nothing? 29. When we did side, 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 and side, angle, side, what did you have to know about the corresponding sides? Nope, nope. That's regular side, angle, side. The angles need to be congruent, but the sides need to be in the same. Sides needed to be in the same. What about them though? Like what makes 4 and 8 and 12 and 24 so special? Because if I change this to 23, Billy, they're not similar. The sides have to be in the same. Begins with an R, ends in atio. Ratio. They have to be in the same ratio. Everybody good? That was painful. Everyone else, if we're going to use side, angle, side, and side, 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 side need to be in the same ratio. All right, well, now we're about to do statements and reasons proofs. How many proofs have I given you this year where the diagram had actual numbers on them? Exactly, none. What am I trying to show you here? We're never going to be able to use those in a statements reasons proof. There's only one way we're going to prove triangles similar, and that is by angle, angle. All right, so when we do a statements reasons and they ask us to prove them similar, the only way we're going to do it is angle, angle. All right, so let's go with this first one. Pretty easy one, I think. It's also a good midterm review because a lot of these theorems are old theorems. I'm given parallel lines, WR and VB. First, prove why the triangles are similar. So you need two pairs of angles that are congruent. Where are they? All right, where are the two pairs of congruent angles in this diagram? Can you see one pair for me? Two, can you see any? The vertical angles, yep. So step 2, angle WSR is congruent to angle VSB. Vertical angles are congruent. That's an old one. Where are the rests now? I need one more. I just need one more pair. That's it. Just one more pair, and they're similar. Two again. Yep. Angle R and angle V. Ooh, what is the reason for this one? R and V being congruent. 17. Nice. There's an old review one. And do I have two pairs? Yes, Emma, sorry. Yep, in the same statement. Yep. I got two pairs of angles. Now I can say the triangles are similar. This isn't going to be too bad today. Tomorrow we get a little bit more crazy, but so WSR, BSV are similar. Take a quick check. Do you write congruent or do you write similar in the statement? Self-respect, self-respect. Yep. You could. Instead of saying the vertical angles or those alternate interior, yes. Anything else? Okay, there's a part B. It's not part of the statement's reasons, but now I know they're similar. What do I know about their sides now? Here we go, Billy. They're in the same ratio. Corresponding sides are in the same ratio. So SB is 10, WS is 15. SV is 20. What's the length of RS now? Again, not part of the proof, just a little algebra question. I'm going to have somebody set me up a correct proportion. What sides match up? Because now they're equal. Here we go, 6. Here we go, 6. 14. Give me a pair that match up. Okay, so 15 over 10 is in the same ratio as x over 20. And again, multiple ways you could write that ratio just as long as you're cross multiplying 10 and x and 15 and 20. Yep, I'm not going to do those for free. So whenever you're ready, let me know what x ends up being. 10 whenever you're ready. Oh boy. How about 15 whenever you're ready? 30, thank you. Any questions? All right, one more proof because I'm not going to spend all day on these because you only need to find 2 pairs of angles. We got a lot of triangles in this diagram, so just make sure you are aware, highlight if you want, trace it. The 2 triangles I need in this one, BAD and BEA. BAD. All right, remember 2 pairs of angles. It's a rectangle, maybe that'll get us something. I got perpendicular lines, maybe that'll get us an angle. Or something you see on your own. $15 again, see any angles up here? Okay, I'll take the DAB, but if I go QDA, you see how that angle is not a full angle in either triangle. You see that? So I'll take this one right here, that's a right angle, because that's in the large triangle. So if there's a right angle in that one, where's the right angle in triangle BEA then? Where's the right angle in triangle BEA? 21, where's that triangle? Where's that right angle? In triangle BEA. Yep, there you go. All right, but hey, they're right angles for 2 different reasons. So I'm not going to put they're both right angles in the same step. Does everyone see that? Or maybe you don't, but you'll see it in a second. They're right angles for 2 different reasons. So first, let me start with angle DAB is a right angle. What told you in the givens that DAB might be a right angle? 19, what told you? All right. 13. Okay, so a rectangle implies all right angles. Something we used last unit. AEB is also a right angle, but for a different reason, not because this is a rectangle. Look in the givens. How did we know AEB was a right angle? 10? Oh boy, this is going to start getting me fired up here soon. 10 again, yep. How about 4? Perpendicular lines form right angles. And just like every time we've done this, what are we going to say about the right angles? They're congruent to each other. Okay, that's only one pair though. That's only one pair. I am still searching for a second pair. Let's go. 1, Maddie. Yep, everyone see angle EBA? It's contained in both triangles. Nice find. And then once we now have both pairs of angles, so the triangles are similar. Questions on the proofs? Not too bad, right? You just got to find two pairs of angles and you're all set. Questions from you guys? Okay, here we go. Now now a couple algebra problems to finish this. I debated whether or not to do this with you, and I think it's just going to cause more confusion. So you can just totally get rid of that theorem up top. You don't need it. You can do these problems without it. I'll show you. You're more than capable. 4y, 6, and 9. I forgot to copy that diagram in here. Okay, so here's this first one. I don't think we're doing anything new. Here you go. These are parallel, right? 4, 6, y, 9. Okay, ready? Find the value of y now. So the fact that they gave me these parallel, that means the triangles are similar. What's the 4 match up with? Don't say anything. What's the 4 going to match up with? 26 here. 4 is going to match up with 10. And the y would match up with, watch your mouth here. What would the y match up with? 22? Okay, y, it's got to match up with the full side though, Mal. It's got to match up with the full side. 9's not a full side in either triangle. Y plus 9. Everyone see that? Y plus 9. Okay, so 4 matches up with 10. Y matches up with y plus 9. I don't need that theorem I was going to show you. So 4 times y plus 9 equals 10y. I'll let you guys, when you're ready, finish that. When you're ready, 11, when you're ready, let me know. Thank you, Fiona. 6. Nice job. No issues there? Algebra's not too bad, right? Until you get here, and then you just started hating things. All right, here we go. They're parallel. Good. That means the sides are in proportion. Triangles are similar. 1 dB is x. EC is x plus 2. I'm missing something here. AE is x. Ooh, all right. All right. I don't know, does that fool anybody that it's tipped on its side now? All right, give me a side in the smaller triangle. Let's start this off. 26, give me a side in the smaller triangle. 1. What does the 1 correspond with in the larger triangle? Now be careful here. AD, which is a length of 1, corresponds with what in the larger triangle? What am I writing right underneath it? 25. 1 plus x. Everyone good there? Not 1x, 1 plus x. Stop, everybody good? All right, what's the other side in the smaller triangle? It is x. AE, which is labeled x. All right, be careful. What does AE match up with in the larger triangle? Combine your like terms. Let's roll. 14. Nice job. Where'd you get 2x plus 2? He added the sides. Hey, also, take a look up here. I see this a lot every year, and I don't know where it comes from, but it screws with people's minds. Don't write that, because then they go cross multiply, and they're like, oh, what do I do? Right? Simplify it before you cross multiply it. Thank you, Caleb. 6x. 2x plus 2. All right, let's have some fun. Cross multiply. It's going to be a good time here once you see what's happening. Oh, 17. Cross multiply for me. One x. Yes, thank you. Don't put plus 1, plus 1x. Hey, what's the highest exponent showing? X squared, right? Why do I say that? Because if that's the highest exponent showing, probably going to have to factor. Let's get one side equal to 0 for me. Leave your x squared positive. Move over the 2x and move over the 2. 19, when you're ready, let me know what it's equal to 0. Not here. Look at that. 8. Oh, look at that. Shocker. 29. Here we go. X squared. Move over the 2x. What do we end up with? What are you moving over here? Okay, how do you move the 2x over? X minus 2x. X. Okay, combine it though. X minus 2x, what is it?
Oh, negative x.
Okay. How do you move the 2 over? So it becomes minus 2. Now, hey, if you are really nervous about your factoring ability, you can always use quadratic formula, what we used yesterday. Okay, that will solve anything. All right, but being in this level of class and the time amount we have, we're going to factor. 2 numbers that multiply to? -2, but add to? -1. 2 numbers that multiply to 2. I don't know what else I can do for you there. Oh boy, 7. Yep, that was an excellent answer. 25. 2 numbers that multiply to -2 but add to what? -1. -2, +1. Nice job. And then, yep, solve each for 0, right? So x equals 2 and x equals -1. We could have a 10-minute awkward staring contest right now until somebody tells me there's a problem. What's my problem, Matt? This had a diagram with it, didn't it? If I take -1, there's a problem right here, isn't there? You can't have a negative side length. So, oh, what happened? Sorry, what happened? Oh boy, I just totally deleted that, huh? Can we go back? There we go. Yep. So I take that -1, and fellas, like most of your high school dating life, maybe rejected. All right. We keep 2. Is everyone all right? When we plug in -1 here, I get a negative side length. I don't know if that's possible. Unless you're a -1 foot. I don't know. All right, next up. I want to see what you can do on this on your own. I'm going to walk around. Billy, go ahead.
On the last one,
Yep.
you have to plug in the x and find the sides.
Well, what did it ask for? It asked for to find dB, right? What did we label dB as? It said find dB, right?
Yeah.
What did we label dB as? X. We found X. So I didn't need to go back and plug it in. what's this 6 match up with? Or this side, right? The 6s don't match up.
Yeah.
So they shouldn't, what's,
So it's the 6 match up with 6 plus
okay, so combine those like terms, what do you end up with?
x plus 5.
Okay, so 6 over,
X plus 5.
yep, equals x over 6. Find the sides that match up. Good, good. Oh, hold on. They match up, right? And then x and, okay, but x times x, 2x.
Yeah.
We got to distribute, oh, come on now. We got to distribute, right? X times x, x squared
Oh, x squared
plus,
plus 5x.
okay, come on. Go ahead, Emily, you can go on. Not yet. Okay, there we go. Hold on, guys, just let me stop this.